Welcome to this presentation on survey sampling methods. In this session, we'll explore how to select a representative sample from a population to gather reliable data. When planning a survey, determining the appropriate sample size is crucial to ensure that the results are both accurate and reliable. The sample size depends on the desired confidence level, margin of error, and the estimated proportion of the population. By carefully calculating the sample size, we can design surveys that yield meaningful and trustworthy insights into the population we're studying. The confidence level reflects how certain we are that the sample accurately represents the population. A 95% confidence level means that if we were to take 100 different samples, approximately 95 of them would contain the true population parameter. The margin of error indicates the range within which the true population parameter is expected to fall. A smaller margin of error requires a larger sample size, as we seek more precision in our estimates. The slide displayed here represents the formula for proportions. The formula provided calculates the minimum sample size needed for a given confidence level and margin of error. In our example, with a 95% confidence level and a 5% margin of error, we would need a sample size of approximately 385 respondents. It's important to note that if the total population is relatively small, we should apply the finite population correction to adjust the sample size downward, ensuring that our sample remains representative without being unnecessarily large. Survey sampling involves selecting a smaller group from a larger population to estimate characteristics of the whole. It helps us make informed decisions without studying everyone. Sampling matters because it reduces costs, saves time, and lessens the burden on participants. With the right method, we can still get high-quality data. There are two main categories of sampling: probability and non-probability. Probability methods involve random selection, non-probability methods do not. Simple random sampling gives each individual an equal chance of being selected. For example, selecting 50 students from a school of 500 using a random number generator. Systematic sampling involves picking every KTH individual from a list. For instance, selecting every 10th name from a voter list after a random start. Stratified sampling divides the population into strata, like gender or age groups, then samples randomly within each. It ensures all subgroups are represented. Cluster sampling divides the population into clusters, often by geography. Whole clusters are randomly selected, like surveying all households in 5 chosen villages. Convenience sampling chooses people who are easy to reach. For example, surveying people at a nearby mall. It's quick but often biased. Judgmental or purposive sampling selects individuals based on the researcher's knowledge, like interviewing healthcare workers to evaluate a hospital's services. Snowball sampling is useful for hard-to-reach populations. Initial participants recruit others, like in studies on drug use or rare conditions. Quota sampling sets quotas to ensure certain characteristics, like gender or age, are represented. But the selection within those quotas isn't random. When choosing a method, consider the population, study goals, available resources, and the level of precision you need. Common pitfalls include sampling bias, missing important groups, non-response, and generalizing beyond your sample. Avoid these to maintain data integrity. To summarize, match the method to your research needs. Probability sampling is more accurate but costlier. Non-probability is quicker but riskier. Thank you for your time and attention throughout this presentation on survey sampling methods. I hope the insights shared have been informative and valuable to your understanding. If you have any questions or need further clarification, please feel free to throw comments. Thank you once again.